Just a little bit ago in the P85 video, I talked about upgrading the bogies to bearing wheels. I did not intend to do it so soon, but testing for my upcoming Simmons Charger model convinced me to pull the trigger on 2 sets of these, one set for each P85. Without a doubt, the bearing axles should perform better than the Technic axles and even stock wheel sets, but can we quantify how much better? Let's take a look at the bearing wheels themselves. These came from Brick Model Railroader and cost $14 for a set of 8 wheels on 4 axles. This seems expensive at first blush, but when the smallest Big Ben Bricks wheels cost $1.50 for a single wheel, $2 more for the axles, bearings, and Technic bricks feels like a steal. Furthermore, everything comes pre-assembled and packed in a perfectly reasonable clamshell. As for the test, originally I wanted to roll cars down a fixed ramp and see how far they would run, but after some back and forth, we decided to vary the slope of the ramp instead. We would measure the angles at which the test car started rolling rather than the distances traveled. This required less track and less space, though perhaps a more complicated testing rig. For the test vehicle, we used a P85 body on simple bogies aimed at limiting any confounding factors. Theoretically, the weight on the wheels shouldn't matter. You will see this in the calculation at the end, but I wanted to get a subjective feel for how the P85s behaved with the different axle options. For the test track, we taped some pieces to a board and built a small gantry to slowly raise one end. We would lift the board and record the height at which the test car started to roll. After each run, we would spin the bogies and the wheels in order to mitigate the noise from part imperfections, but we still sampled each configuration 5 times and threw out the potentially outlying top and bottom results. The Technic axles, of course, fared the worst. These needed up to 100 millimeters of lift to get going. Lubrication, in this case a drop of machine oil, did help a little, but this reduces wear on the parts more than anything else in practice. Mounting with a bearing plate in the center of the axle instead of bricks further out may have some effect, but we did not test this at this time. The stock wheel sets performed significantly better, often only requiring 1/3 of the lift to start rolling. The results also had a slightly tighter spread. We only tested the oldest variant of this part, metal axles going through the entire wheel, as we did not own any copies of the newest version, the integrated plastic axles and wheels.
So it was like 4.4-ish.
I didn't expect the bearing axles to perform that much better than the stock wheel sets, but they moved with almost no lift at all. In fact, they rolled so well we couldn't align them with our starting mark. On level track, the wheels would settle into the valleys caused by imperfections in the track elements themselves. So now we can do a little bit of math to determine the rolling resistance of each wheel assembly. We already have the average height, but we need to take off a bit to account for the thickness of the board. Then, with one leg and the hypotenuse of a right triangle, we can derive the opposite angle using the inverse sine and then the actual coefficient of friction with the tangent. As shown here, the weight of the car does not affect the calculation. With that, the final results are 0.07 and 0.06 for the Technic axles, 0.02 for the stock wheels, and 0.009 for the bearing set. While this test technically measures static friction, we deemed the differences between these values a good enough proxy for the differences between the kinetic friction of the various setups. As a sanity check, 0.02 is an accepted coefficient for ball bearings, and our number basically falls in the same order of magnitude. How well does this work in practice? For just the two cars, it probably doesn't matter except for weaker locomotives, though it could make a difference with more cars. To give a feel for the practical effect, on straight and level track, a single RC train motor can move a Technic axle P85 at notch 2, and it can move a bearing axle P85 at notch 1. This seems almost trivial, but you also have to look at curves which have more sources of friction than just the bearings. The train motor can barely push a bearing axle P85 through an R40 curve at notch 1, whereas it flat out can't push a Technic axle P85 through the same curve at any notch because it doesn't have enough weight. Anyway, that's it for now. These will feature in the future Simmons Charger video, so stay tuned for that, and have a nice day.
No, I mean, look at it up close when it hits the turn. It's still wobbling like it's...
That's nonsense.
I swear.
That's nonsense.